Okay, today we're going to see these problems on pulley. Cable AB passes over the small ideal pulley C without a change in its tension. Okay, what length of cable CD is required for static equilibrium? CD static equilibrium in the position shown. Yeah, so they do it very carefully. Yeah. What is the tension T in cable CD? Yeah, so what is the question wants you to calculate the tension in the CD cable, and then yeah, making sure that they are stable. Yeah, so you can directly analyze, I guess, the pulley C. Yeah, here you have T, right? The one that you asked, but the angle is unknown now because the angle depends on the equilibrium. Here you will have 50 pound, and then here you also have, I would say, T1. Let's call it TA. Yeah, tension to the A. So that we don't know, that should be 45 too, right? Because if this is 90, this is 45, this is 45, right? Am I right? Yeah. Okay. But anyway, what we want to know is what is the value of TA. As far as I teach you before, since this is R, this is also R, means that if you take the moment at the center of the pulley C, it should be 0, right? There should be equilibrium, and then your TA will also be 50. Why? Because TA times R equals 50 times R. TA is 50, right? Yeah, this is the one that we found. That's the moment equilibrium. To make it static equilibrium, they have to be equilibrium in X and Y direction too, right? So let's calculate. Sigma Fx equals 0, right? The Fx will be, but one thing I'm sure, that in the X direction, which is this one, right? The T, it has this horizontal components, and the TA also has horizontal components, right? So T cos theta, this is the theta, which I don't know what is the theta is, equals TA cos 45 ang, yeah, 45, yeah, because this is 45, 45, right? This is also 45. So and then we need to find projection on X directions. Let me draw carefully. Yeah, this is the TA cos 45, right? Is there any other forces in the X direction? No, right? Only on both of them. So the T will be TA cos 45 is half square root of 2 divided by 1 over cos theta, that we don't know yet. And then sigma Fx, sigma Fy, they have to be equilibrium in y directions too. So we know that the TA in the positive direction, we have a TA cos 45, right? This TA has a vertical projection, plus the T also has vertical projection. If this is theta, that is sinus theta, right? T sine theta, okay, which I don't know what is the theta. and then minus 50 equals 0, right? And then again, t sine theta will be equals to 50 minus ta square root of 2. Am I right? Yes, I'm right. And then if I divide it by sine theta, and then divide it by 1 over sine theta, this will be gone. And then if I equate those two equations, because t should be equal to t, right? Then 50 divided by sine theta minus ta over sine theta times square root of half square root of 2. Am I right? This should be equals to ta per cos theta half square root of 2. Am I right? 50 sinus theta minus 50 sinus theta of equals ta is 50 cos theta. All right, and then 50 minus 50 over 2 theta equals sin theta. Am I right? Yes, I guess so. Equals to 50 over 2 theta 1 over cos theta. All right, so if I put sin theta above, so this will be tangent theta equals to 50 minus 50 over 2 theta times 2 divided by 50 square root of 2. Okay, so then you can calculate the theta. Let me calculate first. So your theta should be equals to 22.5 degree. Your tension T will be equals to 50 square root of 2 1 over cos 0.5. You can calculate by yourself. Yeah, and then the length of L. What is the length of the cable? So here if we draw here, yeah, this is theta 22.5. And we know that this is 2 inch. Yeah, so what is the length? Sine, yeah, sine theta equals to 2 inch divided by the length. So length is 2 inch divided by sine theta. What is the length? 2 divided by sine 0.5. It should be equals to 5.23, and that is the length of the cable. Yeah, and this is the angle theta, and this is the tension. Let's calculate the tension to make it complete. 38.29. Yeah, hey, sorry, that's not L, that is the tension theta 29. Yeah, so this is the tension So the TA is 50, but this T is 38. I guess it's logic since this A wire is more vertical compared to this CD wire, which is more horizontal. Yeah, because the angle theta is 22.5. Here is 45, so it makes sense that T is 50 and T is 38 something. Yeah. So I think that's it for today. It's quite challenging question actually, with a lot of calculations and geometry, but the idea is simple. You just need to calculate a free body diagram, draw first. Yeah, draw the free body diagram first, and then taking the moment, you get TA. Once you get the TA, you need to check equilibrium in other directions. Sigma fx equals 0, sigma fy equals 0, and from sigma fx you get the relation between T and TA with cos theta. With the sigma Fy equals 0, you also have the relation with T, TA, and also sinus theta. And then by equate those T, you can get what is theta. Theta is 22.5. Once you get the theta, you can calculate T, and you can also calculate the L, the length. Okay, so I hope you can follow me. If not, then try to rewind the video, yeah, so you understand. You need to practice yourself. Okay. And I think that's it for today. See you again in the Pulley problems. Bye.